Okay, so what we're doing on this chapter is we're comparing distributions. So we've already learned how to make histograms, stem and leaf, and box plots, but now we're going to talk about what we're going to do with them when we're comparing two different distributions. One thing that's really important here is when comparing them, you have to use comparison words. Comparison words. So like larger, smaller, things like that. If you don't compare with those words, then you're going to lose some points. If they're both symmetric, remember you're going to describe them using the mean and the standard deviation. If they're both skewed, you're going to use median and IQR. And then lastly, if one is skewed as one symmetric, you're still going to use median and IQR. There is something in each year I teach stats, I learned something a little different. There is one thing that I want to make sure that I saw the other day, and this is what we're going to do. We're going to use, for box plots, we're always going to use IQR and median. I think originally I might have said mean and standard deviation if it looks roughly symmetric, but really we can't tell if it's unimodal. And so we're just going to use the IQR and median because it's there. All right, so when you make histograms, highlight these three different things. When you make histograms, the important thing to do is that you have to have matching axis, and you have to have the same bins. So if one bin goes by 8, the other bins have to go by 8. You can't make one bin go by 8 and one set of bins go by 10. Okay, so stem and leaf. What happens for this one is the stem is in the center, and you have leaves that go to each side. And so this one over here would go this way. So you can kind of see what happens. And so this one, if I turn my screen, this is going to be unimodal and skewed to the right. This one on the left would probably, I would probably consider that one bimodal. Okay. And remember, you have to include the key. You don't have to include the key for both. You could still just include the key for one. So 1/2 is equal to 12. Okay, when you do box plots, it's really important still for box plots that you're going to draw one axis. You label the big number and the small number, and then you do halfways in between. We don't want to see all these other random numbers. We want to have consistent tick marks. Okay, when you do a box plot, when I'm going to be, and your plot doesn't have to match mine exactly. The things that I'm going to look for is that if this is group A, first of all, you do have to label it group A, group B. But let's say group A's max is 20 while group B's max is 18. I'm going to look to make sure that group B's max is higher. Let's say they have the same quarter 3, so I'm going to make sure that they line up here. Let's say that group B's median's a little bit bigger, but its quarter 1 is the same. So I'm going to look to see how they are relating to each other. If one's supposed to be a little bigger, it's a little bit further to the right. And then we'll say that this is supposed to go to 10. Okay? So I'm looking to see that if they're supposed to be the same, like right here, quarter 3 for both of these was supposed to be 15, I can tell that they're in the same spot. Quarter 1 for both of them are supposed to be in the same spot, and I can tell they're both at around 11 or 12. Okay? But again, you also have to label it. Okay, so we are going to do one summary real quick. And I know you don't have this picture unless maybe you printed it out, but it's a good one to have. So remember, you're going to do socks, but you have to talk about it in context. Okay, so I'm going to type instead of, what's it called? Instead of me writing it, drawing it out. Okay, so the distribution of shoulder girth for male and female. Let me draw my box a little. Are both unimodal and roughly symmetric. You could possibly say that the female is a little skewed to the right, but I'm okay with you also saying roughly symmetric. So that takes care of my context, okay? And it takes care of my shape. Now I need to talk about outliers. There are possible outliers for females at about, I think that's 128. They're counting by, looks like they're counting by 16, so 128, with a gap from 117 to 126, or 125, 124, something like that. And it's actually 126, not 128. Okay. For males, there is a possible outlier at 135 with a gap from 132 to 134, or to 135. Okay, so that takes care of my shape and my outliers. Now I need to talk about spread. Now, we're going to say these are both roughly symmetric, and so symmetric would mean it's kind of in the middle. So I think mine right here, I think my mean is at about 118. And right here, I think my mean is at about 99. Okay. And then let's talk about spread. So spread, we're going to use standard deviation. Now we talked about this a little bit. Usually from the center to the right or center to the left, there's 3. What we're going to do is we're going to find the whole distance. This whole distance is from 100 to 136. So we're going to do 36 divided by 6 because there's going to be 3 to the right and 3 to the left. So my standard deviation is about 6. And over here, this one looks like it's 83 to 131. And so I'm going to subtract those. I think that's about right, yeah. And it might be 130. So it's about 48. And so now I divide by 6, because again, there would be 3 to the right and 3 to the left. So this standard deviation is a little bit larger. Okay. All right, so let's type that in now that we have that information. The mean shoulder girth for men is larger at 118, while it is only 99 for women. The spread for women is larger at 7 than for men at 6. And I should probably say at about, only about 99. So we have all of our information, and probably should add an about up here too, just to make sure that we're kind of estimating. There is an issue with this graph though. If we looked at our rules, the first rule we said is that they need to have matching axes and bins. And so this one doesn't match. So if we, and I can't really zoom in because it's not a very clear picture, but for this one, this goes from 80 to 86. And so for this one, each bin is 3. But this one goes 100 to 104, so each bin is 2. So if we wanted to force this to be a more accurate graph, we would have had them both start at the same spot. So they both would have started at 80, and then they both would have ended at 134, and then they would both have to go by 2 or 3. Okay, but again, If you leave out this comparison word, so it's larger, if you leave out a comparison word, you're going to lose points. So you have to make sure that you actually compare the center and the spread.